The first earthquake looked like the main event. Then, 39 seconds later, a stronger one hit. That is what made the Venezuela twin quake so unusual. Not simply that the ground shook twice, but that one earthquake may have changed the conditions for the next. In earthquake science, this kind of close pair is often called an earthquake doublet. It means two significant earthquakes happen close together in time and location. But this is not only a Venezuela story, it is a global earthquake question. How can one strong earthquake be followed by another strong earthquake almost immediately? The short answer is stress. The fuller answer is stress transfer. A fault is not just a crack in the ground. It is a zone where blocks of crust move relative to each other. Some parts creep slowly. Some parts stay locked. And some parts store stress for years, decades, or longer. When one locked part finally gives way, the fault slips suddenly. That slip releases energy. The ground shakes. But the rupture does not only affect the section that broke, it can also change the stress around it. Some nearby parts may be relieved. Other nearby parts may be pushed closer to failure. And that is the key. If another section was already close to breaking, the first earthquake can help push it past the limit. That is how a second strong quake can happen soon after the first. Not because the earth randomly shakes twice, not because the ground opens like a movie crack, but because connected fault sections can respond to a sudden change in stress. Picture a fault system as several locked sections under pressure. One section breaks first. The balance changes. Another locked section receives extra stress. If it crosses its limit, it can break too. That second break may happen later. It may happen minutes later. In rare cases, it may happen only seconds later. This is why twin quakes are different from the ordinary aftershock pattern people expect. Most earthquakes are followed by smaller aftershocks. One big quake, then smaller shaking afterward. But sometimes, the first quake is not the largest. Sometimes, a stronger quake follows. When that happens, the first earthquake may later be called a foreshock. The larger earthquake becomes the Mainshock. But those labels are usually understood only after the sequence unfolds. In the moment, the first earthquake may look like the main event. Then the second one arrives, and the meaning of the first quake changes. This does not mean earthquakes can be predicted. Scientists cannot look at every earthquake and say a bigger one will arrive in seconds. Many earthquake sequences fade. Many produce only smaller aftershocks. Only some produce a close pair of strong earthquakes. That is why doublets stand out. They show that faults do not always fail in one clean movement. A fault system can have bends, branches, rough surfaces, locked patches, and old weaknesses in the crust. One part can break without breaking the entire system. Then the rest of the system adjusts. This is the real lesson behind twin quakes. An earthquake is not always one isolated moment. Sometimes it is part of a sequence. The first shock can change the fault system. The second shock can reveal how close another part was to failure. For people, the lesson is simple. After strong shaking, do not assume the sequence is finished. Stay away from damaged or unsafe structures. Expect aftershocks. Follow official updates. And treat the first quiet moment with caution, not panic. Twin quakes are not a mystery. They are not proof of prediction. They are a sign that faults behave as systems. One rupture can change stress. A nearby section can respond. And if that section is already close to failure, two earthquakes can strike very close together. That is why earthquake danger is not only about one magnitude number. It is also about fault geometry, stress transfer, timing, and how connected parts of the crust respond after the first rupture. Understanding that does not tell us when the next earthquake will happen, but it explains why one earthquake is not always the whole event. Science, not panic. Preparedness, not fear. If you want more global geology documentaries that stay calm, clear, and grounded in science, subscribe to the channel.